Roads are more than just pathways. They're lifelines. Yet over 1 billion people lack reliable road access, cutting them off from schools, jobs, and healthcare. At the same time, traditional asphalt roads are devastating for the environment, releasing millions of tons of carbon dioxide annually. What if we could fix this? Not just with any roads, but with sustainable, durable, and eco-friendly ones. Hello everyone, my name is Salak Mian.
And my name is Elijah Park, and our project is called FuturePave. We're taking on UN Sustainable Development Goal 9.1. Roads connect us, but for 1 in 7 people globally, they remain a luxury. The lack of reliable roads traps impoverished communities, isolating them from essential resources. For example, farmers in rural Kenya face a 50% reduction in market earnings due to inadequate infrastructure. Meanwhile, traditional asphalt production is one of the most carbon-intensive industrial processes, contributing 1.6 million tons of CO2 annually. The problem is clear. Our planet and its people deserve better. Our solution? Replace asphalt with geopolymer concrete, a material that not only reduces carbon dioxide emissions by around 60% compared to traditional Portland cement, but also uses industrial byproducts like fly ash and slag. The innovation turns waste into infrastructure, creating durable roads while combating climate change. Our initiative targets underprivileged regions, collaborating with local governments to train workers and build sustainable road networks that provide jobs and opportunities long after construction ends. Now, let's talk about the suppliers we chose for geopolymer concrete. After careful consideration, we selected 3 companies that align well with our project's needs. Wagner's. Known for their earth-friendly concrete, Wagner's is a global leader in sustainable construction materials and has a proven track record in large-scale projects. Zeobond. A pioneer in geopolymer technology, Zeobond offers large-scale production capabilities and extensive experience in international projects. Geopolymer Solutions. Specializing in high durability concrete for industrial applications, they bring expertise and reliability to meet infrastructure demands. These suppliers provide the expertise, quality, and capacity needed to make our initiative a success. Let's talk about the sites we chose and why they matter. We put careful consideration into selecting these regions. We focused on areas with critical infrastructure needs like deteriorating trade routes and key highways. We also prioritize regions vulnerable to extreme weather where durable materials like geopolymer concrete are crucial. By 2030, we aim to complete a pilot program in one of these countries and plant seeds in 5 others, which means setting them up so they will be fully prepared with funding and agreements to begin construction. Funding for this initiative will come from public and private organizations that focus on sustainable, climate resilient infrastructure. We carefully chose them because they align with our goals, have experience funding large scale projects, and prioritize impactful solutions in underserved areas. The Green Climate Fund, GCF, backs climate resilient infrastructure along with our CO2 reduction goals. The Asian Infrastructure Investment Bank, AIIB, funds sustainable development in key regions like Pakistan and Bangladesh. The Global Infrastructure Facility, GIF, supports underserved areas, aligning with our mission for sustainable growth.
Geopolymer concrete costs around $120 to $150 per cubic meter in North America and $110 to $140 in the Asia Pacific, depending on factors like material availability and transport. The amount of geopolymer concrete required depends on the width and depth of the desired road. The cost of construction and the size of the required labor team varies with location and project size. However, purchase and rental costs for equipment and machinery must also be considered. Here's our plan to ensure this project's success and sustainability. Step 1. Needs assessment. Identify areas most in need, places cut off from essential services like schools and markets, and focus where we can to make the biggest impact. Step 2. Stakeholder engagement. Work with governments and community leaders to secure approvals and align goals. Step 3. Securing fundings. Submit proposals to funding partners like the Green Climate Fund and AIIB, emphasizing the long-term benefits of geopolymer roads. Step 4. Pilot implementation. Build a pilot project to test materials, refine methods, and demonstrate results to stakeholders. Step 5. Scaling up. Expand to other areas using lessons from the pilot, adapting to challenges, and building momentum. Step 6. Monitoring and evaluation. Track performance, measure impact, and report progress to ensure continuous improvement. This isn't just about building roads, it's about creating opportunities, connecting communities, and transforming lives with sustainable infrastructure. Our goal is clear: By 2030, we'll complete a pilot program in one country, proving the effectiveness of geopolymer concrete roads, while preparing 5 more countries to launch their own projects with funding and agreements secured. By the end of 2025, we aim to conduct research in local areas, secure funding from partners like the Green Climate Fund, and finalize plans with local governments. Between 2026 and 2028, we aim to build 5 to 10 miles of road in the pilot country, monitor performance, and refine methods for scalability. Between 2029 and 2030, we prepare 5 additional countries by securing funding, finalizing agreements, and publishing pilot results to attract investments. And by 2030, we'll have 1 completed pilot and 5 countries ready to begin laying the groundwork for global expansion. Large-scale infrastructure projects come with challenges, but we've developed strategies to address them. The first risk that we might encounter is shaky timelines. Delays from logistics or funding gaps are common. To stay on track, we're planting seeds in multiple locations and creating backup plans for sourcing and staffing. Another risk we may encounter is trade disruption. Geopolitical instability can disrupt supply chains. In order to combat this, we're diversifying suppliers across Australia and the US and may offer incentives to promote commitments. The third risk that we may encounter is government reluctance. Concerns about costs or new materials can cause hesitation. Pilot projects and evidence from successful past geopolymer projects would demonstrate the material's value and economic benefits. Past projects like the Belt and Road Initiative struggled with poor materials and mismanagement. By focusing on durability, collaboration, and sustainability, we're avoiding those pitfalls and building a stronger foundation for success. Why would countries adopt our solution? Because it's about more than making roads. It's about transforming lives, communities, and the planet. One benefit that countries who adopt our solution may see is an economic growth. Roads boost local economies by connecting people to markets, schools, and healthcare. A 10% increase in road density can raise GDP by 1.5%, especially in developing regions. Another benefit is job creation. From construction to maintenance, this job creates immediate and long-term jobs, providing economic stability in underserved areas. The third benefit that they may see is climate impact. Geopolymer concrete cuts greenhouse gases emissions by 309.35 kilograms of carbon dioxide per cubic meter of concrete produced, and recycles millions of tons of industrial waste annually. Another benefit is improved access. Roads reduce travel costs by up to 40%, making essential services and opportunities more accessible, especially for marginalized groups. The last benefit that they may see is global development. Aligned with the UN SDG 9, this initiative improves climate resilience and sets a standard for sustainable infrastructure.
With that in mind, let's get started.